My name is Bowden Kelly. I'm a program manager at Microsoft. And today I'm pretty stoked to be here to talk to you about TypeScript, and specifically TypeScript's relationship with JavaScript. Just a real quick show of hands. Who has heard of TypeScript? Good. Everyone. Great. Who is currently using TypeScript? Excellent. So we got a lot of new people, and hopefully we can get you started quick. Couple key objectives for this session. I want you to understand why TypeScript. For those of you who aren't using it yet, you need to understand why you should even go try it. And so hopefully we'll cover that in detail, and you'll understand why it's worth your time. I'm then going to show you how to get started fast. We're going to put TypeScript in a project very quickly, and then we're going to convert an entire Express project and show you TypeScript in action. So first, let's talk about why TypeScript. Why should you care? We think developers should be able to focus on creating amazing things. We have all these tools, all these frameworks, all this technology, but all it's there for is to help us create stuff. And more times than not, that's not what we do. If you think about your day-to-day activities as a developer, you can basically bucket all of your tasks into these three buckets. You have understanding code, and that contains reading source code, tracing execution, finding bugs. You have maintaining code, which might be fixing those bugs or refactoring and preparing for new code. And finally, when you've paid all of that tax, you've done all of that work, then and only then can you start actually creating the experiences you set out to create. Who's heard of Project Monaco? A few of you? Who's heard of VS Code? Most of you. So VS Code came from Project Monaco, and Project Monaco came from the idea that we want to create this editor in the browser, have a really rich editing experience that we can put in any browser on any platform. And so, of course, we made this in JavaScript, and it was a massive project. After the first couple 100,000 lines of code, it started to get difficult to make any progress. After about 700,000 or 800,000 lines of code, we realized that we weren't really making any progress. And in fact, when we sat back and measured kind of where our time was going on this massive JavaScript project, we found that 95% of our time went into understanding and maintaining what we had. This project was effectively read-only. That's 2 hours in a 40-hour week that we actually got to build this editor in the cloud in a browser, and that just wasn't good enough. And so it was with this problem we started grappling with it. It was like, well, we like JavaScript. JavaScript is good. We want to use JavaScript, but we need more tools. We need to be more productive with JavaScript. And so we said, what would it take? What kind of tool would it take to turn our breakdown into something like this, where we could take these minor savings from understanding and maintenance and feed them back into creation time? What would that tool look like? And it was chasing that goal that we created TypeScript. TypeScript is, by definition, an optionally typed superset of JavaScript that compiles back to plain JavaScript. But I've always been more of a show than a tell kind of guy, so let me just give you a quick run through. So here we have a plain JavaScript file. Nothing special here. This is just ES5. We've got functions, if statements, nothing special here. And to get started with TypeScript, all I'm going to do, and this is in VS Code, all I'm going to do is add a comment that says tscheck. And what this is going to do, it's going to signal to VS Code that, hey, I want to treat this JavaScript file as if it were TypeScript. I want you to run the TypeScript type checker on this code and just tell me what you find. And so here you see we now have red squiggles. And this is coming from the TypeScript compiler in the background is looking at all of the types that exist in this JavaScript. And it's telling you where things don't really match up. And let me show you what I mean. So here we have this error that says argument of type, this object literal right there, is not assignable to the parameter property descriptor. And so here we're calling this function. And if we actually look at this function, there are types that JavaScript expects behind the scenes. Just because it's dynamically typed and we can change them whenever we want doesn't change the fact that they're still there. And so sure enough, there's this property descriptor parameter that's expected, and inside of it, it's basically a property bag of config options. And so here we have these 6 options: configurable, enumerable, value, writable, get, and set. And if we look at what we put read-only. Probably what we intended to do was put writable, but we put read-only instead. And so what happens in JavaScript when you do this? At runtime, we're going to start executing this function. We're going to take this property bag, try to configure this function to act in some specific way. And we're going to come across read-only, and the engine's going to look at it and throw it away. And it's not going to tell you what it did. It's not going to tell you that it ignored it. There'll be no warnings, no errors, no nothing. But now this function is not configured as you expected. It's behaving in a way that you probably didn't intend. And so that's a bug that you now have to track down by hand with a debugger, line by line, until you find that this was, in fact, just a mistake from reading documentation, and probably what you wanted was writable false. TypeScript will look at these types, and it will tell you when things are off. And that's primarily what TypeScript does as a type checker. It takes your JavaScript and applies extra checks to it. Let's look at another example. We have operator greater than cannot be applied to the types a function that returns a number and number. And if we look at this, sure enough, we have ship weight, which is a function that returns the parsed int of some text element. And we're comparing it to 100 to make sure that this package is not overweight. Probably what we intended to do was actually call this function. But sometimes you're kind of in the heat of things, typing along, and you forget to call the function. And what happens in JavaScript at runtime? JavaScript will compare this function and a number, and it will return false. Why will it return false? Because JavaScript hates you. This is probably not something anyone ever intended to do, compared functions as numbers, but it's valid. In JavaScript, you can do that, and it will return false. And so every time this code runs, it's not going to behave the way you want it. Again, you're not going to have errors, and you have to go find this by hand, debugging step by step. TypeScript will help you find these little mistakes. TypeScript will cover your back. But we haven't done anything special here, right? This is just JavaScript. I haven't done anything out of the ordinary. And so what we can start doing is adding types. There are places in JavaScript where we can't guess anything about the types. For example, function parameters. Of course, in JavaScript, if I ask for one parameter, you can give me 3 or 0 or a different parameter than you expect. And so TypeScript knows this, and it'll say, hey, this type is of type any. That means it can literally be anything at runtime. I can do better than that, and I can actually tell it with this JS comment exactly what type I want it to have. And so here, this comment above says, we really want this to be a string or a string array. And when I add that type annotation via this JS doc, TypeScript now knows that this is a type that I want to type check. And so it's no longer an any, it's a string or a string array. And this type will follow email address throughout the entire function body, and sure enough, we found another error because of that. Here it says property trend does not exist on type string. This is just a typo, probably meant to type trim. But this happens all the time. And in JavaScript, you won't find out until runtime when you get an error that says trend does not exist on email address. But TypeScript can cut that feedback loop down. It can make it quicker. And this is only able to be done when you give it types. But at the same time, you don't have to give it types. For example, we have another function here that there's really not much happening. There's no need for me to add a type here. I'll just leave it as any and move on. And so this is all just type checking JavaScript. Again, we have not converted this to a TypeScript file yet. And really the point here is TypeScript is JavaScript. TypeScript is just an additional layer of type safety added on top of JavaScript for you to use when you want it. It's an optionally typed superset. But what if I do want to convert it to TypeScript? What does that change? So I'll remove tscheck. I'll change this from food.js to food.ts. And now I have a TypeScript file. And of course, I did not disable tslint, so we'll get a bunch of tslint errors, but that's fine. And so the big difference with a TypeScript file is instead of having to use JS comments to add types, you can now add them directly in line. And so I can just say, this is a string or a string array. And sure enough, TypeScript takes in those types the exact same way as if I had done a JS comment. But it's just a little easier and a little faster. That said, now that we have inline annotations, that is not valid JavaScript anymore. So I need to compile those types away. So the second half of TypeScript is the TypeScript compile step. And so I'll go ahead and pass foo.ts into the TypeScript compiler. It will give me back a JavaScript file that is basically identical. And if we look at this, the only difference here is really that parameter we have no longer is decorated with a type. We stripped it out. And so now you have plain JavaScript again in your JavaScript file. So at runtime, everything is good to go. That's not the only thing it does. It strips out the types, but it also is capable of down-level compiling your code. If you write ES6 code and you want it to be ES5, TypeScript can do that for you. So let's say we have a class, and we want at runtime, in Node, it doesn't matter. You can have ES6, and it's all good. But if for whatever reason you wanted to run your code in an environment or an older version of Node that did not support ES6, TypeScript can down-level it. The default is to emit ES5 code. But you can choose whatever target you want. And so here you can see we have this ES6 class on the left, and it gets turned into a function prototype-based class on the right. And so this is very powerful depending on what targets, environments you're using. You can always pick the common denominator where you want your code to run, but still write with the latest and greatest features. So that's TypeScript in a nutshell. So when I say optionally typed superset of JavaScript, you saw that I can add types where I want to, but I don't have to. And then when it compiles to plain JavaScript, it all starts with JavaScript, but at the end of the day, you're running JavaScript as well. And so it's that simple round-trip conversion. And so you saw how easy it is to get started checking JavaScript today. You can take any JavaScript file you have, add tscheck to the top of the file, and you're off to the races. Maybe you'll find some bugs, maybe you won't, but it's worth to start experimenting with a type checker and how you can make it work for you. You can then add JS docs to further add type checking to your files and start playing with what it feels like to have types in JavaScript. So you get it. TypeScript is adding type checking to JavaScript. But does that actually work? Does it help? A lot of people say, I'm the greatest JavaScript developer on the planet. I never have type bugs. All of you are wrong. Just kidding. But they did some research a while back to see how many bugs out there could be saved by type checking in JavaScript. And some researchers at the University College of London took 400 projects on GitHub, and they tried to apply TypeScript to them to see if bugs that had made it into production that were later fixed could have been caught by a type checker. And what they found was 15% of those bugs would have never made it into production had they been type checking that code. So that's pretty cool. So the next thing we're going to do is we're going to look at how to add TypeScript to an existing JavaScript app, specifically Express. And so I'm going to pop open this app real quick. And here we have a very standard Express app. I have MongoDB running in the background. We've got a few controllers. It's very simple. I can run this by saying node source server. And then you will see it's a very, very simple app. It's powered by Passport, so we can log in. And you see it's very simple, right? Just a boilerplate that most of you have probably seen before. And it's all JavaScript. And to get started converting all of this to TypeScript, I'm going to add a tsconfig. And to do that, I can type tsc --init, and it will generate me a tsconfig file. And when we look at this tsconfig file, we see there's a ton of options. And this is just the generated output of our tsconfig generator, and it's showing you all of the possible options there are with a brief description of what is there. I'm just going to delete all these because I already know what we want, and then configure this as so. So we are targeting Node, so ES6 is fine. CommonJS modules is the outputted modules when we compile. CommonJS makes sense for Node. We want to do module resolution Node. Basically what this does is it tells TypeScript to resolve all the modules we find as if they are Node modules. This is slightly different from other module systems, and so we need to specify. We're going to do allow.js true. This basically allows us to feed JavaScript files into the TypeScript compiler. I'm going to briefly show you what it would be like to convert a project file by file, and that's what you need allow.js for. And then we're going to add an includes. Oh, we also need an out directory. We're going to be compiling our source into, we'll call it dist, just so we can keep our TypeScript separate from our runnable JavaScript. And then finally, we'll do include. And this will basically tell the compiler to look at specific files but ignore others. For example, we have this copy static assets JavaScript file that's just a helper function, and we don't want to include that. And so we'll just say anything in the source folder should be consumed. And so now you'll see when I run tsc, we will pull all these files out of the source directory and compile them into the distributable directory. And in this case, we're actually not really doing anything. We're just passing in JavaScript and taking out JavaScript. And so you can see these files are basically identical minus maybe some white space. So the next thing I'm going to do is I'm going to convert this server.js to server.ts. And just like that, I'm now in TypeScript land. So I can start adding type annotations wherever I want. If I wanted to create a new function and add a type, I can now do this. And if I call that with the wrong argument, you can see we're getting type checking. And all of this just happens because we're in TypeScript. And that's great. And so you can see at this point, you could convert your files one at a time, right? The rest of my files are still in sources JavaScript, but server TS is in TypeScript. However, all of it's getting compiled to JS on the other side, which is my executable JavaScript. And so at this point, if I had 10,000 JavaScript files, I could convert them one at a time if I wanted to. We have not a lot of JavaScript files, so I'm going to go ahead and convert them en masse real quick. And so now you'll start to see we do have some errors. And I'm going to walk you through how we can iron all of these out. And so if we pull back open our problems window, you see we have quite a few compiler errors now. And a lot of these are cannot redeclare block scope variable, blah, 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 right? And if we look at these, they're all import problems. And the kind of short answer for this is modules are super complicated, and everyone did it differently for a long time. And so no one has the same module structure. And so when you're converting from plain JavaScript to TypeScript, TypeScript prefers that you write everything in ES6 modules, and most of this syntax is currently using CommonJS, and so there's a kind of disconnect. This is actually really easy to fix, though. It's just a syntax thing. And so I will open my sketchy regex.txt and show you how simply we can just convert some of these things. And so basically, I'm going to search for all of the places where we're doing this require import. And there's 29 of them. We import quite a bit of stuff here. I'm just going to replace them all. And you'll see some of these errors start going away. But of course, if we do the imports, we also need to do the exports. Again, modules are super complicated. There's actually whole other talks going on kind of the module conflicts. If you're interested, I strongly recommend you check them out. We're going to kind of gloss over that now, though. But there's basically two kinds of module exports we have to address. One is literally module.exports. And that syntax needs to change to just export equals instead of module.exports equals. And so we'll go ahead and do that. And the other is exports dot, which needs to change to export var. And again, we'll just change all of those real quick. And so now we've just a couple regex functions. We've fixed basically every single import. You see there's still a couple mistakes. Express validator is one of these examples. If you look at express validator, we're actually exporting a function that's a little more complicated and not really expected, and so we have to do something slightly different. And so here we'll replace that syntax with import express validator equals require. These are minor edge cases. Again, there's a lot of details behind how this actually works under the covers, but you can get around it with just some basic syntax. Go ahead and close that. Now, we have some more errors. Let's see. We have this module resolved to a non-module entity. And so when we look inside of user, we see that, again, we're doing this kind of export of a function. Mongoose model is the function that creates Mongoose models, and we're exporting it directly so that we can create user objects or documents and do searches and whatnot. And so what we need to do here is instead of having this export equals, we want to just say export var user equals mongoose model. And this will allow us to import this user just directly, and now we have this function user that we can now use as we expected. And it's all good. Moving on, we have another error now where we have property ID does not exist on type empty object. And if we look at this user, we see that it's coming from serialized user. And serialized user has some types. And this is the part where I kind of lied to you. We're not completely doing the entire conversion all in front of you because I went ahead and downloaded a bunch of typings files. What typings files are, or DTS files, if you're unfamiliar, is they are the types that power third-party libraries. And there's a large community of developers on a GitHub repository called Definitely Typed, which have spent a lot of time taking libraries like Express and Passport and writing all of the types for every single function and every single variable and every constant that's defined in those libraries. We can, as TypeScript developers, we can then import those and use those types to get better type checking when we're using those libraries. So you can see if I go to my package.json, we have all of these dev dependencies, which are at types async, connect Mongo. Every single one of these is connected to a DTS file. And if we look at the node modules folder, they're under the at type scope. And we can go look at the types for any of these libraries. And again, this is work that people have done for us, and we can just benefit from by just doing a simple npm install. I've gone ahead and done that already. And so here we have the passport types. And if we look at serialized user, we have all of the types for passport here. And they're saying that we're expecting this empty object, and there's no ID on empty object. Well, the problem is we have this user, and it's actually a document. It's not really an empty object. And so we can go ahead and import that type from Mongoose. And then tell the type checker that this is, in fact, a document. And so we'll go ahead and do that. And once you have a document, users have IDs, and all documents have IDs. And so we now get not only completions for all this stuff, but the type checking is now sound as well. But that's actually not good enough, because this user document we defined, we actually ended up tacking on some methods and additional fields. And so what we could do at this point is we see that user.compare password, compare password is not on document. We could just say, you know what, I don't really care about the type here. I'm just going to put an any on it and ignore types for now and move on. But we can actually do better than that. So instead of putting an any on it, we're actually going to create the type for user. So I'm going to come back to user. And again, we'll go kind of grab this just for the sake of time. But I basically created an interface which defines the type of this document we made. And by dropping in this interface, and we'll export it as well, you can see we have email, password, all these properties we added, as well as the compare password function. And we added types to all of these things. And so now when we go back to our passport, we can decorate this with a user document instead of just a document. And you'll notice that I haven't imported it, but I can use VS Code to auto-import that for me, and you'll see we get user document up here. You'll see now our error has gone away, and in fact, when we try to reference this user, we get all of our properties that we added, as well as the functions we added. And so adding types can give you just a little bit more support in your tooling. But again, if you want to, you can always just slap an any on it for time's sake. Moving on. We have two more errors. This one, we look at it, we can see cannot use new with expression whose type lacks a call or construct signature. This is a situation, again, with the import. Our user, we're trying to do this as the normal ES6 import, but really we just need to import the user that we switched earlier. And now you can see all of our errors are gone, except for this pesky tsconfig error, which we're going to pretend like it's not there, because I've never seen that before. So now we have no more errors. If we run tsc, you'll see that it will take all of our TypeScript files. It will compile them. It will dump them into the distributors folder. It will run the type check. It came back clean, so we have no errors. And now if we run node on the dist folder server, we can see that everything does, in fact, still work. Oops. And I can log out and do all the things I would expect. But everything's now TypeScript, right? And so in just, about 10 minutes, we were able to take a basic Express app, kind of convert all of the imports and exports, start adding types and creating them in modules when we wanted to. But now we can proceed however we want. We can type as much or as little as we feel. And so we can look at some other examples of where we can add types to make things easier. Here is a very common. We have request and response coming in, this callback. When I type request dot, I get nothing, right? Because we don't know what this request is. This request is an any. It could literally be anything. We can do better than that. And so we'll go ahead and import from Express itself request and response. And these are types that will tell us exactly what these request and response objects hold. And so now when I put request on this type and response, you'll see that our completions get much better. as well as the documentation that comes with it gets better. And so if I want to look at the render method, I can see the docs that go with it. And so this saves you time from having to go pop open the Express documentation, read exactly what parameters render could take. If you want to, you can go to definition on this, and you can see all of the different options that come in, or even the overloads for the redirect method. And it just makes your life a little easier. But again, you don't have to. You can use it wherever you want to, but not everywhere. So you might be thinking, types are great. I want them everywhere. I want you to tell me every time I could be doing better. And we actually have a solution for that. It's the strict flag. And we can set that in tsconfig. That is not what I want. You can set that in the tsconfig just like any other option by adding strict true. And this will basically tell the compiler, go do every single check you know of. I want all of it. And so it'll do some extra strict null checking. It'll check functions. And as you can see, I have about a bazillion more errors. It'll even tell you every place where you could have a type, but you haven't added one yet. And so if you look at all of the other request responses, they will come up with an error. And this is useful if you want to get the most checking possible. There's a lot of potential in the TypeScript compiler, but again, it's strictly optional. You can use it when you want. You don't have to use it all the time. But this kind of compile, write code, compile loop is kind of tedious. So I can show you real quick how to set that up in VS Code to make it a little easier. I'm going to go to my package.json, and this project is powered by npm scripts. And so we're just going to add a TSC watch task here. And I'm going to pass in TSC with the -w flag, which is just running TSC with a file watcher. And now I can add to my main watch task a TypeScript step. This is basically using concurrently, which is a package that just runs multiple external tasks at the same time. You see I have a Sass compiler, I have node.mon running, and now I'm going to add TypeScript. This will basically allow us to constantly be compiling and recompiling all of our TypeScript code. And so we'll say TSC watch. And now when I say npm run watch, you'll see it's kicking off the Sass compiler, the node.mon process, and TypeScript. And every time I change anything, it's going to recompile. It's going to launch node again if we have to, if it crashes, and it's going to recompile all of my Sass, which is cool. So now I can just launch this watch task in the background, ignore it, and then go to town writing code, and my server will constantly be updating in the background. One last little tip that's pretty cool. If you open tasks.json, you can actually map this to your normal build task. This is the default build in VS Code that's Control-Shift-B. If I say, instead, I want this npm script to call watch, I can now kill this process, hit Control-Shift-B, and it will run my npm run watch task. And so now when you launch VS Code, you can hit Control-Shift-B, it will launch your watch task, and now you're off to the races. All right. So hopefully you got to see a little bit of what TypeScript can do, but if you've never used TypeScript before, I encourage you to start with tscheck. Just grab any one of your JavaScript files, throw tscheck at the top, and just see what happens. Worst case is it comes back completely clean, and you're awesome. You also can add TypeScript to any workflow. I showed you Express here today, but you can add TypeScript on top of front-end code, back-end code, any node library. It's really for you to use however you want it. This was just a simple example. It's also worth mentioning that this example is a subset of a larger example we maintain at Microsoft TypeScript Node Starter. If you want to see everything we did here and use that as a template to play around with, if you just go to this project, you can clone it, and it has all of the tasks built in for you. And it's a great place to start. And then finally, of course, TypeScript lets you focus on creation. The point of all these tools at the end of the day is to help us build more cool stuff, whether it's Node or TypeScript or any libraries. And I encourage you to take a step back and think about the tools you're using and how you could be more productive and focus on shipping better code. Thank you.